Okay, so let's say we are trying to find, and you might want to put this somewhere on your paper or something. We've got a point up here. We'll call it x1, y1, and we've got a point over here, x2, y2. We're trying to find the distance here, but check it out. I'm going to make a right triangle. Did that not just become the hypotenuse of that right triangle? Okay. This length down here, this horizontal length, if I know x2 right here, and is this not at x1? So if I subtract those, and it doesn't matter which order you do it in, if I do the right minus the left, x1 minus x2, okay, that's going to give me that distance right there, horizontally. Vertically, up here is y1, down here is y2, so y1 minus y2 is going to give me that vertical distance. So that's where the subtracting the points comes from, okay? If it's a little hard to see with x's and y's, let's just give them let's give them values, okay? Let's say this is 4, 9, and let's say this is 1, 6. No, I don't want them to both be the same thing. 1, 5. Okay, so if I give them values, tell me this. How much horizontal distance is there from here to here? From 1, x equals 1 to x equals 4. So that's a distance of 3. 4 minus 1 is 3. From here, this y value is 5. This y value is 9. So what's the vertical distance between these two? 4. 9 minus 5 is 4. Okay, so that's where the subtracting the values comes from. And then if we just apply the Pythagorean theorem to this, square the leg, add them together, take the square root, you get that hypotenuse. And that hypotenuse is the distance between those 2 points. Okay, so that's where that formula came from. Somebody didn't just make it up and be like, oh, great, it works. Okay, it actually came from the Pythagorean theorem. Okay, so let's find the distance. Okay, let's find the distance between these points, 5, 3, and 9, 9. Distance equals the square root of x minus x. It really doesn't matter which one you do, okay, as long as you keep the order the same. Okay, so if I do 5 minus 9, I got to do 3 minus 9. If you would rather do 9 minus 5, that's fine, as long as you do 9 minus 3. And technically, it really doesn't even matter then because we're squaring them. You just got to make sure you pair the x's together and pair the y's together. All right, now, I'm not going to type all this into my calculator because I want to leave it in square root form. So I'm just going to type in what's under the square root. And actually, I'm not going to type it in. I'm going to do some mental math. 5 minus 9 is negative 4. Negative 4 squared is 16. 3 minus 9 is negative 6. Negative 6 squared is 36. 16 plus 36 is 52. Let's review simplifying square roots. Is 52 divisible by a perfect square?
No.
Yes.
Oh, yeah.
What's it divisible by?
4.
4. Okay. So the square root of 4 is 2. So 2 goes on the outside. What are we left with? 13. Okay. So it is equivalent to 2 square roots of 13. That is the distance between those 2 points. Now, sometimes we do need to know the actual value. So then we can just type it into our calculator and get 7.21, okay, approximately 7.21. But I wanted to review the simplifying the square roots because that's going to come into play. All right, let's do another one like that. 8, negative 8, and 0, 1. So distance equals x minus x squared plus y minus y squared. I almost said x again. 8 minus 0 is 8. 8 squared, 64. Negative 8 minus 1 is negative 9. Negative 9 squared is 81. 64 plus 81 is 145.
145. It's not divisible by 25. It's not divisible by 9. I doubt it's divisible by 16. So I think that's all we can do. That I don't think we can simplify 145 unless somebody sees something that I don't. No, I think we're in the clear. So that is approximately, if we needed the actual distance, 12.04. Exact, square root of 145, approximate, 12.04. Okay? So let's think about this. In the context of a circle, how might we use the distance formula?
Find the diameter.
We can find the diameter. If we had the two endpoints, we could find the distance between those, and that would be the diameter. What if we had the center and an endpoint of the radius? What would that give us?
That gives half of it.
That would give us half of it, which is the
Midpoint.
the length of the radius. Okay, if we had the center of the circle and we had a point on the circle, that distance would give us the radius. Okay, so we may need to use the distance formula. It depends on what they give us. Okay, if they give us the center and a point on a circle, that would give us the radius. If they give us the two endpoints of the diameter, that would give us the length of the diameter. Yes, sir.
So if we were on test and we forgot one of